Dear students, today we are going to discuss about Fresnel half period zones and zone plates. Suppose we have a plane wavefront, say ABCD, right? And due to this wavefront, we want to find what is the intensity at a point P. Suppose B is the distance from the center of the wavefront to the point P. Now Fresnel suggested that we can divide this wavefront into a number of regions or zones. Certain regions or zones which are called as Fresnel zones, right? So those zones are circular. It is like this, then this, then this, and so on, right? Now why are these called as half period zones? The reason is that the path difference between any two waves that move from the adjacent zones is lambda by 2. That means these zones are to be so imagined, they are to be so constructed that the path difference between any two waves that come from the adjacent zones should be lambda by 2. That means if this distance is b, this should be b plus lambda by 2. And for any nth zone, this distance should be how much? B plus n lambda by 2. Now we name these zones as say M1, M2, M3 and so on, right? Let their corresponding radii be R1, then R2, R3 and Rn. Now let us try to find the radius of the nth zone. That will be Rn, right? We can find that from this right angle triangle using Pythagoras theorem. That is very simple. So Rn square plus B square is how much? Is this much, that is B plus n lambda by 2 square. So this is Rn square, that is radius of the nth zone, plus B square plus B is equal to B square plus n square lambda square by 4 plus B n lambda, right? So B and B will go, since lambda is very small, right? And it is a square term, so we'll neglect this term. B will go with this, it will cancel with this. We are left with Rn square is equal to Bn lambda. Bn lambda. That means Rn is under root Bn lambda, or we can choose to write it as it is root n root B lambda, right? For the first zone, n is 1. So R1 is, say, R is equal to B lambda only, under root B lambda. Similarly, R2 will be root 2 times this B lambda, or it is root 2 times R. Or in general, we can say that the radius of nth zone is root n times R, where R is the radius of the first zone. R is R1, right? Next, we intend to find what is the area enclosed by each zone, and that is this. Suppose we find the area enclosed by the nth zone. How can we find that? It will be the area of the nth circle minus the area of n minus 1th circle. So, the area of nth zone will be area of nth circle minus area of n minus 1th circle. So let's do that. So that will be pi Rn square minus pi Rn minus 1 square. So this is pi. What is Rn? We have already found that. So Rn is root of Bn lambda. So it is Bn lambda root, and then it is square. Now this is pi times, what is this? This will be root times b n minus 1 lambda square, right? So this will be simply nb lambda pi minus pi times b n minus 1 lambda. So it is nb lambda pi minus again nb lambda pi plus this term, this will be n lambda, not n but lambda only, lambda b and pi. So this and this will go, we are left with lambda b pi only, and this term is independent of n, which implies that all zones have same area. Remember, the zones have a different radii obviously, but their areas are same, right? Now to give a practical realization to this half period zone idea, this theory, an optical device was constructed, and that optical device is called as zone plate. This is similar to construction of a diffraction grating to realize the practical arrangement of end slits in case of Fraunhofer diffraction, right? So you have a plain glass plate, and again by means of a fine diamond pointer you draw concentric circles, right? Now it can be done in two ways. Either the central portion, the central circle or the first circle will be bright. So if the first zone is bright, or in other words, if the odd zones are bright, first, third, fifth, seventh, if the odd zones are transparent and even zones, that is 2, 4, 6, 8, etc., are opaque or dark, this is called as a positive zone plate. Then it is called as positive zone plate. And if the odd zones are opaque or dark and even zones are transparent, then it is called a negative zone plate. But remember, in both cases, when we draw the concentric circles using a fine diamond pointer on a plain glass plate, the relation of the radius remains this. That is, the radius of every nth circle will be root n times the first circle, right? So the radius of any nth circle will be root n times the radius of first circle. So that is all about Fresnel half period zones and zone plates. You are going to learn more about it in detail in the lab course. That's all.